Okay, we're finishing 3.4 a little bit before we go on to section 3.5, even though this is titled 3.5. We are doing and taking a look at example 6 because you're going to need this to do some of the exercises. So this is before we start 3.5. We were just talking about the fact that on page 126, at the top of the page, there are two equations. H equals negative 16t squared plus h naught is if you're going to drop something, but you add an extra term, a t term, if you're going to launch something. H equals negative 16t squared plus v naught t plus h naught. And we're actually doing number 61 on the exercises, page 128, having to do with a lacrosse shot. And since in that problem, the ball was thrown, we are going to use this. H equals negative 16t squared plus v naught t plus h naught. You need to understand what these things mean. This right here is the initial or beginning velocity. This number that you plug in for this V naught right here could be a positive number if you launch the ball upward. It could be a negative number if you're spiking the ball downward, as in a volleyball example. If you're hitting the ball downward from the top of the net, then this number will be negative because it's going down. But in this example, the lacrosse example, this number will be positive because the guy threw the ball upward. This is still the beginning height. This is how high it was when that launch actually took place and we started the clock to time it. So this is the beginning height. And this right here is the height after some time has elapsed. So this height, this thing right here is always changing as time moves along. So to do this problem, we're going to say h, which we can predict at any given instant of time. H is going to be negative 16t squared plus 90t plus 7 because he launched it at 90 feet per second. It says so in the problem. Do you see it? That's the velocity. And he launched it from a height of 7. What the question asks is, how long is the ball in the air? Is that a T question or an H question? T, which means there's got to be something that allows us to replace this H. Because right now, we have an equation that's written in T as a variable and H. What else in the problem tells us what we can put here?
3 feet.
Yeah, the guy caught it at a height of 3 feet. So when the height of the ball was 3 feet high, we're asking how long did that take? That's the ending height. This is the beginning height. Does this make sense to you? Okay. In order to solve this, this is a quadratic. In order to solve it, it needs to be equal to 0 first. We're going to subtract the 3 from the 7. And I really, really don't want to do this problem by trying to factor it. I don't think it will. That 7's not nearly big enough to give me that 90 in the middle.
Is it 4 instead of 7?
Oh, yes, it is. Thank you. Thank you. Forgot the arithmetic. Thank you for that. Yes, it's 4. It's even worse now. I'm not going to factor that. Here's the deal, though. My other option, instead of factoring, is to use the quadratic formula, right? I don't know if you remember my warning, but I'm warning you again. You do not want to use the quadratic formula with a negative a. You don't want to do that. Causes all kinds of problems that aren't necessary to even have to deal with because you can avoid it. What I'm going to do is instead, what I should have done is taken all of these over there instead. What I'm really going to do, though, folks, if you think about it, if you took all of these terms over to the other side of the equation, wouldn't that just change all their signs? And instead of doing that, I'm just going to run a negative through it. Did you catch that? Now I've got things in a proper way so that A is positive. I'm going to find those zeros using the quadratic formula. So here we go. T is going to equal. It's not X equals because the variable is T, and it's going to be the opposite of B, plus or minus the square root of b squared minus 4. And a times c is 16 times negative 4 is negative 64 over 32. You could have done those calculations in your head if you're not really good at squaring things or multiplying things. A times c was negative 64. So the next thing we do now is multiply 64 times 4. You get 256, right? plus 8,100 is 8,356. I think, if you're doing the arithmetic with me. Does that seem right? Now, the next question is 8356 a perfect square? How do you find out? You square root it. You go square root 8356 and see if you get something whole. It isn't, right? That's okay. Keep that number in your calculator because that's what the square root's going to be. Now you want to take 90 plus that over 32 and 90 minus that over 32. Because that's your plus minus. What was the square root of 8356 as, say, to the nearest 100? 91.4? Remember, this is what t equals. So what's 90 plus 91.4? Hit enter and then divide by 32 and tell me what you get. 5 point what?
67.
Okay, and what's this one? 0.2.
It's negative 0.03.
Like this? Can you understand that this makes no sense? This is the certain number of seconds before the ball was launched, which just makes no sense in the problem. So this one, because there's context in the problem, this one can be thrown out. 5.67 seconds is how long the ball was in the air. Also, makes not a great deal of sense to me. You ever watched a lacrosse game? Can they launch them in the air so that it stays in the air for nearly 6 seconds? That's like somebody going, 6. That's stupid. Nobody launches the ball that hard. So whoever wrote this problem should not have said 90 feet per second. That's a really hard thing to do. To launch a ball that hard with your arms or with a lacrosse net or something like that. This is more like maybe somebody that shoots an arrow that doesn't have their bow drawn full back, just a little bit, just shoots it and it may stay up in the air that long. But that's a dumb number. I don't know who made that up. But we answered the question. The answer is between 5 and 6 seconds. They want it to the nearest 100th or something, don't they? What does it say? How long is the ball in the air? It doesn't say, but I bet it does on Big Ideas Math. If you did your assignment on there, this is what they have. Of course it's not here. I don't know what they have. But I bet it tells you how much to round it in the Big Ideas Math if you did it there. If not, I'll take any reasonable answer. Anything between 5 and 6 seconds is fine. Other questions? Anybody? Okay, whatever it takes, get that finished up and submitted either on the computer or on paper. And if you are all done, you'll turn it in right now or get submitted or whatever. But we're moving on unless there's any last minute questions. Yeah.
So with the volleyball one, would that be like,
Your V would be negative.
okay.
V naught would be negative because the projection is downward. And so because it's negative, you're going to come up with a very tiny number. You know how quickly the ball can hit the ground. When somebody spikes it, hits it hard.
And that would be like an object is launched at one.
What's that?
It would be like an object was launched at one.
Yeah. They're asking how much time has the person on the other side, the digger, got to get under it. That's not much. Okay. If there's nothing else, we're moving on to section 3.5. Okay. This one is called solving nonlinear systems. Do you remember what a system is? You guys solved them for the last test. Well, some of you did. Remember, for example, when we wanted to solve it with the calculator, we had 3 equations with 3 unknowns. We went to the simultaneous equation solver. Remember that?
Yeah.
Okay. The one thing it doesn't say in the name of that on the calculator is that it's only for linear things. Linear means every variable has an exponent of 1. Let me remind you what your types of linear systems might have been. If you're doing, I don't know, raisins and sunflower seeds and peanuts, and it was 9 pounds. Remember this from your test?
The first test?
Oh, this was chapter 2. And there might be a value, maybe it was $2 for raisins, $1.50 for sunflower seeds, and I don't know. I don't even think this is right, but it was $14.50, I remember. And then there was one other equation like negative r plus 2s plus 0p equals 0, if you did it right, something like that. And then you grabbed your calculator and you did simultaneous equation solver, right, in your polysimul. The only reason why you were able to use that in your polysimulator is because every one of these is understood to be 1. If any of these variables has something other than a 1, that program won't work. That app won't work. It's for linear systems. Well, what have we been discussing this chapter? We've been discussing quadratics, and they have a power of 2. That's how you recognize them. And so the simultaneous equation solver in your calculator where you solve ones like this isn't going to work anymore. You're going to have to rely on your algebra skills. But this is called a system of 3 equations in 3 variables. We will be solving systems of 2 equations in 2 variables. In other words, we're going to be sticking to things that can be graphed on this grid because it's got an x and a y, and that's all. There's not going to be any z part of it. And your systems are going to be made up of things like a quadratic equation and a line, or 2 quadratic equations. Or even today, you're going to be doing circles and lines. But all will be able to be drawn on that grid, so it's going to be 2 equations with 2 unknowns, x and y, and we're going to show you and figure out how to solve those things. You can do it on your calculator, you just can't use that app. So let's start with some of the algebraic ways of doing it. We'll just jump into example 1. I don't want to do example 1. I'll come back to it. Remind me, I got to come back to example 1. Let's start with example 2. Example 2 says, solving a nonlinear system means at least one of the equations is not a line. By substitution, this is our system. X squared plus x minus y equals negative 1. By the way, this is a quadratic. It's not in any sort of form that you're used to recognizing it in, but look, y has an exponent of 1, and at least one of the x terms has an exponent of 2. That's like saying y equals something with an x squared in it. It's just not quite in that form. But this is a quadratic equation. And the other one is a line, x plus y equals 4. This is your system. And what we're looking for, as we were with linear systems, is where are the points on this grid where this quadratic, or parabola, crosses this line. Here's your possibilities. You might, let's see, this has a positive leading coefficient if we kick the y over, so this thing's going to open upward. These are your possibilities here. Either the line will hit it twice, or the line might just snug by it and hit it once, or the line might never hit it at all. So you'll either get 2 solutions that I'm looking for this point and this point on that grid if we graphed it, this point here if we graphed them, or perhaps no points at all if we graphed them and found out that they didn't cross. Well, I'm not going to graph them. I'm just saying you could get 2 or 1 or 0 solutions. We're going to do it algebraically with a thing called substitution. In the line, because these have a 1 coefficient, one exponent, especially if these have a 1 coefficient, it's a really easy thing to solve for one or the other of them. And I'm going to solve it for y, and I'll tell you why I chose that one in just a minute. By tossing the x over to the other side and subtracting, I now have y equals something with an x in it. That's the first thing. Get one of the variables all by itself. And then rewrite the other equation and substitute that y right there with what y is equal to in the other one, since they're in the same location on the grid. Did you follow that? And in doing that, you now have an equation that has only one variable in it. All we have to do is clean it up and solve it. That's what you've been practicing the entire first 4 sections of this chapter to do. So I'm going to have to clean it up. I've got x squared plus x. I'm going to distribute this negative. It'll be minus 4 plus x equals -1. And I'm going to do two things at once here. I'm going to combine the x's, and at the same time bring the 1 over and add it. Did you catch that? Everybody okay on the algebra? Now, at this point, I have 3 ways of solving this. You just got to choose one. You could factor it, which it will, because there are factors of 3 that subtract to be 2, and those numbers are small enough you can tell really quickly. That's what I'm going to do. You could graph it. You could also quadratic formula it. Those are your 3 possibilities. I'm going to factor it because it goes really quick. X and x, factors of 3 that subtract to be 2 are 3 and 1. To get a positive 2, I need the 3 to be positive and the x to be negative. That's equal to 0. Each gets their shot at being the 0. If this is the one that's 0, then x is -3. Okay. Rewrite that so it looks right. -3. And if this is the one that's 0, then x is +1. Right? Everybody clear so far? Now I need you to understand what you have here. You do not have a solution. What you have is x coordinates for the solution. Just x's. What I mean is we have discovered a situation like that. We have 2 x's, which means there will be 2 solutions. If I were to put this on a grid like this, something like this, I have no idea if this how it works out. This is -3, and this is the 1. But it's just the x coordinate. In other words, we have this. We know that the x coordinate of one of the points is -3, and the x coordinate of the other point is +1. That's what we know. We've got to go back and find the 2 y values one at a time that goes with it, because this is the answer to the question. What points on the grid do they cross? We've only got the x coordinates of the points. So we plug them back in here would be great, because it's already y equals. I'm looking for a y. This would be a great plug-in. So I would have 4 minus -3. That would be 7. Because the negative is positive. And I have 4 minus 1, which would be 3. So what we're saying is that it's a situation like this, where one of the cross points is -3, 7, if we graphed it, and the other one is 1, 3. But these are the solutions to this system of equations. You follow all that? Please remember, you do not have a point here. You have candidates for the x value of points. You've got to go back and find the y's that go with them one at a time. Don't assume this is a point. That's the biggest mistake people make. Okay? So that's the substitution method. So example 3, I got to keep erasing so I can keep showing people that are watching the video. So I'm going to try example 3 now. I'm going to use another method that you're also familiar with. Show you how it works with a quadratic system. We're going to solve the next system with elimination. That's what the book calls it. I think it's a dumb name, but we're going to go with it. And we have the system 2x squared minus 5x minus y equals -2. And we have x squared plus 2x plus y equals 0. Now keep in mind, I wish I didn't have to erase the previous one, but the previous one, you can't solve it with substitution or elimination. Actually, probably could. Never mind, forget that. When you use the elimination method, you have to have everything lined up. You have to have your x squares in a line, vertical line, your x's, your y's, your equal signs, your constants, and we do in the presentation of this problem. If you didn't have that, you would have to toss things one side or the other until things lined up. Once they line up, you got to ask yourself, if I were to add things together right now, would something add out? And yeah, the y's will add out right now. So if I use the elimination method on this, I have 3x squared -3x, no y's, equals -2. Did y'all follow that? And the result of that gives me an equation that has only x in it. That's always what we're after. Get an equation that has only one variable because you can solve that. Well, the equation that remains by adding out the y's is quadratic, which means we need to set it equal to 0. 3x squared minus 3x plus 2 equals 0. Again, at this point, you've got three choices. To find the x values that might work for these, you can factor it if it will, and I wouldn't spend a long time trying to figure out if it will or not. You can graph it and see if it ever hits this resulting parabola ever hits the x-axis, and if it does, find them. Or you can quadratic formula it. Because I don't have my calculator out and I don't want to get it, I'm going to quadratic formula because I'm not sure if this will factor or not, especially with this 3 on the front. That's always a confusion factor. So I'm going to go quadratic formula. So I'm going to say, in this case, x is equal to positive 3 plus or minus the square root of 9 minus 4, and a times c is 6 over 6. And I'm going to stop right there and say there is no solution. Why? Because the discriminant will be negative. 9 minus 24 is a negative number. I don't even care what the negative number is. It will be negative, and I can't square root a negative and get a real solution. What this tells me, that little tiny analyzation right there, what this tells me is there's no solution for x, which means these two parabolas never hit each other. They never cross. If you were to solve both of those for y, you get y equals something with a bunch of x's in it, and you graph them both, you would get a graph like you see in example 3. You have a blue parabola and a red parabola. Can you see they never hit? Well, in solving systems, we're looking for the points where they hit each other. Well, they don't. So there is no solution. There are no points where they hit. And it was because in trying to solve the resulting quadratic from elimination and trying to solve this, we ended up square rooting a negative. So there's no real solution. Done. That doesn't always happen. Sometimes if there's a real solution by going through this, you get two possibilities for x, and you got to come back up in one of these guys and figure out the y that goes with it, just like we did in the previous one. But in this case, no solution. Okay, the next thing I need to discuss with you is what happens when the system is made up of, instead of a quadratic and a line, or two quadratics, what happens if one of them is a circle? Anybody know what the equation of a circle looks like on this grid? I mean, obviously you can draw circles. Right. Pi is used in figure over this with you so you understand it. But the equation of a circle whose center is at the origin, so we put the center right there and we draw a circle, is actually Pythagorean theorem. You go, what? Pythagorean theorem is all about right triangles. What's that got to do with circles? And the answer is everything. I'll show you. The equation is x squared plus y squared equals r squared, where r is the radius of the circle. So consider this one with me for a minute. X squared plus y squared equals 5 squared. That means the radius of the circle is 5, okay? If I plot that over here on my grid, the center is at the origin. I already told you that would be the case if it was like this. I'll show you if it's not at the origin in just a minute, but it goes, if I go out 5, just so that I can figure out that's going to be the radius length. I just want to get something to shoot for to draw this circle for you. So I'm just counting out 5 so that I get pretty close to it. And I'm going to freehand it because my compass has a pen on it. I don't want to draw on this chalkboard with a pen, so I'm going to freehand this drawing. I just wanted to get these so that I can figure out what I'm aiming for. That's not too bad. This is a little flat down here. Okay, so if that's the circle we draw, radius 5, centered at the origin, I want you to see something really cool. Consider this point right here. That one is where you go out 3 and up 4. And we know that this has to be 5 because that's a radius. And if you'll remember, Pythagorean theorem tells us that if this is 3, squared is 9, and this is 4, which squared is 16, 9 and 16 is 25. Whose square root is 5? So this point right here meets this equation. X was 3, y was 4, turned out to be. 25 for the, 5 for the radius. If I went over here and did it, let's say right here, that would be 4 here and 3 here. And we know that that has to be 5. So it doesn't matter which leg is which. And you're going, well, yeah, that works great for 3, 4s, and 5s. But I want you to understand this. This strange point right, we'll say right here. That's just an arbitrary point of no particular, it's just on the circle. But I'll guarantee you this. However far left, I'm going to erase this right here so that you can see it better. However far left I have to go from the origin to hover right above it. However far that is, it looks like it's about negative 1.8, maybe. And however far down I have to go to arrive there, if I draw that right triangle, knowing that this is 5, then this number right here, and this number right here, whatever it is, maybe 4.6, maybe. I can guarantee you that if I had measured these things exactly, that this squared plus this squared would become 5. So if you take all the points where the x value of it and the y value of it squared and added equal 25 and string them all together, you'll get all the pink points on this circle. So this is any x-y combination, any x-y combination that adds up to 25 when you square them is going to be a point on that circle. String them all together and you got them all. It's a circle. This is a circle. Pythagorean theorem. Weird, but true. Okay. The geometry part that I just explained is neither here nor there for solving the system. You just need to understand a circle when you see it. A circle's got an x squared and a y squared, whereas a parabola only has an x squared. So y is single. But for a circle, they're both squared. So let me show you how to handle one like that. Take a look at example 4. It says solve the system by substitution. X squared plus y squared equals 10, and y equals negative 3x plus 10. What did I say? Y equals negative 3x plus 10? Okay, we're going to have to do this one by substitution because if you were to add this, if you were to get them all lined up, bring the x over, if you were to add the x, you couldn't add the x squared to x, nor could you add the y squared to y. Nothing's going to add out in this situation because this is all to the first power. These are all to the second power. Nothing's going to add out like it did in the last one. So your only option is substitution. And the happy thing about the substitution thing is y on this one is already solved for. It's already done. So we're just going to rewrite this equation and we're going to substitute the y value in it with this stuff. A substitution. So rewriting this one gives me x squared plus not y squared but negative 3x plus 10 squared. Because y was squared here, I have to square its replacement. Equals 10. But again, I have one equation with one variable in it. I just got to remember my algebra to get it solved for. That can be a little rough. First thing I'm going to do is to liberate this and this by foiling out this thing. Remember, it's negative 3x plus 10 times negative 3x plus 10. Remember how to foil a squared binomial? I'm going to tell you. You square this on the front, so that'll be plus 9x squared. You're squaring negative 3 and x. The middle term is this term times times 2. Negative 3 times 10 is negative 30x times 2 is negative 60x. Do you follow? You always square that on the back and it's always positive. So I squared this binomial to get from this step to this one. Are you okay or not? If you can't square this and make sure that you're correct, then write this twice and foil it out, but I'm not doing it for you. You should be able to square a binomial without doing that. So now I combine my like terms, also realizing I'm going to have a quadratic. I'm going to bring the 10 over in the same step. So it's going to be 10x squared minus 60x plus 90. Y'all see that? Everybody okay on that move? There was 2 moves there. Combining like terms and moving the 10 over. Now, as I look at this, remember my options. Once you get to here, the options are graph it, factor it, or quadratic formula it. I'm going to try factoring because I recognize all of these and it might cut the numbers down to where they're small enough that I can factor it. So I'm going to take the 10 out. Not only will it factor, it's a perfect square trinomial if you remember how to recognize it. Remember? Factors of 9 that add up to 6, both 3's, has to be negative. This is a perfect square trinomial. What I end up with is, I'm going to come up here underneath this so that I don't bother that. It's going to be, it's 10 times x minus 3 squared equals 0. Well, 10 will never be 0, so you can ignore it. It'll never be the 0. But this will be 0 if x is 3, and only 3. What does it mean? It means this line hits this circle once. And the x-coordinate of the hit point is 3. That's all we know. But there's only one. So I plug it in either here for x or here for x. This looks like it's a lot easier to me. This would be negative 3 times 3. That's the x value I'm substituting, which is negative 9. Negative 9 plus 10 is 1. So this line just snugs right by this circle at a single point. Let's take a look at the graph. You can graph both of these now that you understand a little bit more. Let's take a look at the graph and see if we can verify that by graphing by hand. You can also graph it on your calculator. Problem is, it's pretty difficult to graph this because it's hard to solve for y. So we're going to graph it by hand. We can graph both of these, you'll see. So, the first one we were given there has a radius of what, do you think? What's the radius of that circle that they give us right at the beginning so I can graph it? No, that's what r squared is. No, you don't divide by 2, you square root. And what's the square root of 10? The answer is, for graphing purposes, a bit more than 3. Because 10 is a bit more than 9, right? Because you can't get accurate on a grid like this, especially the kind of paper I gave you. So we'll just do the best we can. It's a bit more than 3. Is that okay? Okay, so we're going to have the center here is going to go 1, 2, 3, and a little tiny bit more. Not much. And then 1, 2, 3 and a bit. And then 1, 2, 3 and a bit. 1, 2, 3 and a bit. This is just so that I can freehand it. You can use a compass if you want, if ever want. Verify that. That's not great, but we're going to go with it. Then we're going to graph this line. This line is in the form y equals mx plus b. So we start at 10. That's 3, 4, 5, 6, 7, 8, 9, 10. It starts here. And then we drop 3, run 1, drop 3, run 1, drop 3, run 1. Look at that. Drop 3, run 1, draw that line. Look at where it snugs right by the circle. Right there, this was the origin, at 3, 1. Voila. It's a tangent line because it hits the circle in only one spot. Okay? So that's verification that we got the right point, if you can graph them. All right, now, I have only one more thing to show you. It's example 5 on page 135. And I need you to sit up and pay attention at this point, if you haven't been already. Because example 5 is an entirely, completely, totally different use of these skills. And you'll see why when I show you. First of all, I want to remind you that when they presented the systems and the stuff that we've been working on so far today, everything that we have dealt with, every equation had an x and a y in it of some kind. What we're going to do now doesn't have a y in it. And you've got to get it separated and put it in a totally different file in your mind what we're doing. Because some of the skills that we learned today are going to be used to solve this, but what we're looking for is not what we were looking for before. What we were looking for before is a point on that grid where this graph intersects this one. That is not what we're doing now. So get over it. We are going to be dealing with an equation that has no y's in it, just x's, but we're going to use methods that we learned. Oh, well, hang on. I'll go ahead and do both at once. I was going to go back to example 1, but I'm just going to go ahead and show you both example 1 and 5 at the same time. What we're trying to do is solve the equation in A, where there's 2 equations we're going to solve. One of them is 3x squared plus 5x minus 1 equals negative x squared plus 2x plus 1. Okay, you got to listen up here. Pay attention, sit up and watch what's happening because this is different. Notice that I don't have 2 equations that have x's and y's in them that are separate. This is not a system. This is a single equation. One equation. But we're going to use systems solving to find it and to find the solution. And the cool thing about this is you can do this with any equation. If the left side and the right side are really ugly and nasty and horrible, awful to have to work with algebraically, and these aren't that bad. I mean, we could bring all of these over here and they'll all work out and we could have one quadratic and find it. But if you've got a left side that's really gross and disgusting from the right side and combining them together is going to take a heck of a lot of work and it's nasty, what you can do is graph this side in y1 in your calculator and graph this side in y2 so that you're forcing a y into the situation. You're saying y equals this and y equals this, even though there was no y in here. We're using those systems methods to try to find out on the grid where this crosses this. But keep in mind that there was no y at the beginning, so your answer cannot have a y in it. It can only have x's. But using the grid to solve it can be much easier than the algebra involved. I'll turn the TV or the thing so you can see the TV in just a minute. It's a really, really nice solution method, but only if you know what you're doing and don't abuse the calculator and get bad answers. So if I use this method by finding intersect points, then I'm going to have to know how to put both of these equations in. That's pretty easy to do. Come on, baby. Get on there. Oh, I plugged it all the way in. There we go. Okay, I'm hoping, yeah, it looks like they can see this on the, just a little bit like that. Hope you can see both equations. Okay, so now we're going to go to y equals. If there's anything in there, clear it. If your plots are on, turn them off. So the plots are all off. These are all clean. Get that done first. Everybody there? Now we're going to put 3x squared plus 5x minus 1. And then in the y2, we're going to put the other side, which is negative x squared plus 2x plus 1. And we're going to go to a standard screen since there's no context to the problem. It's just a skill. So we're going to go to a standard screen, see what happens. We expect 2 parabolas, one that opens up, one that opens down. And it looks like they intersect in 2 places, right? Yeah? So we're going to go find those. Do you remember how to find those? Places where they intersect? You go to this, trace key. Remember, whenever you're on a graph and you want to know something numerical about it, you go second, calc, and intersect. Just get your cursor, my cursor's right there. Get the cursor closer to one of the intersect points than the other. I'm going to go left first just because I like to do things from left to right. So I'm going to move it down there so it's just closer to that one than that one, and I'm going to hit enter, enter, enter. And I find that it intersects at negative 1.175. One of the intersect points is negative 1.175, comma, negative 2.732. S to the nearest thousand. Now I'm going to go find the other one. You go second to calc again. Down to intersect. But this time, before you hit enter, you got to get the cursor closer to the other intersect point, like right there. Hit enter, enter, enter. And we get 0.425 and 1.670. Everybody get the same thing I did? Were you able to make it happen? Yeah.
One of my graphs is probably the other graph is one.
Okay, then go back to your y equals and make sure you squared your x where you should have. And you can insert. Let me show you. Let me show you something so you don't have to retype. This is good for all of you. Let's pretend that you typed this one like this. Okay, so that it looks like that. And you just want to square this without having to retype all that. You can go up here and you sit on the plus sign. You sit on the thing just behind where you want to insert it. And then the insert, you see over here in the blue line where it says DEL for delete and above it says insert. So you go sit behind it and you go second insert a square. And it will just shove things back without having to retype. Yeah? What?
My calculator just died.
I'm sorry. We'll take care of you in a minute. Okay, so that's how you fix that. And then when you graph it, you get these two guys right here. And then you go find the intersects. Do you know how to find the intersects? Okay, let's go through it one more time. Now that you've got the correct graphs, you go second calc, and you go down to intersect, and then you just move your cursor with your left and right arrows closer to one intersect point or another. I'm going with left. And then when you get it closer to that one, then the other one, you just hit enter, enter, and enter, and it will jump to it. So the X is, this is the point where they intersected. And then you go second calc and intersect, and this time you got to move your right arrow until it's closer to that intersect point, just closer to that than the other one, and hit enter, 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 and go to the closest one. And we get this one. Are you okay? Everybody clear? So those 2 points are the answer, right?
Yes.
Wrong. That's the part you gotta pay attention to. This will kill you. In every other thing that we have done today, these are the types of correct answers. But remember, we used the intersect method for solving this. There were no y's. There were no y's in the original. We forced the issue by using the calculator to graph them. The answers are these, and only these, because only x's can count, because only x's were in the presentation of the problem. These two x values make this equal to this. We just forced the y issue to make it easier to solve. But you've got to get in your head straight what's going on. It is not a point that's the answer. It's the two x values, because the problem was only presented with x's. Do you see what I'm saying? It's a solution method to an equation. Now I want you to look at the B part of example 5. Let me read it to you as you're looking at it. This is what they want us to find. Find the solution to this equation. Negative, parenthesis, x minus 1.5 squared plus 2.25 equals 2x parenthesis, x plus 1.5. Not only is that ugly because we got parentheses and squarings to deal with, we've got to distribute, and we've got decimals all over the place, and it's gross. And I do not want to have to do the algebra behind that because I'm very likely to make mistakes. So what do? Use this method. The calculator doesn't care how gross and ugly the two sides are, as long as you can type it. So to solve this one, I'm not going to do any algebra at all. I'm not going to square binomials. I'm not going to distribute negatives. I'm not going to move things from one side to the other. I'm just going to type. So we go negative, parenthesis, x minus 1.5, close it, square it, plus 2.25. That's what I'm putting in y1, the left side. And then we go 2x, parenthesis, x plus 1.5. Not too bad to type. No algebra, no squaring, no distributing, no trying to work with decimals. Now I'm just going to hit graph. And then I'm going to go to that point of interest right there, and I'm going to zoom in and see if they actually even hit each other, because it looks to me like they only hit at one point. Right here is the interesting area. Remember how to make your calculator work for you. You go trace, and you move your cursor to that interesting point. I don't have to move it far, right there. And then go zoom in, and it will center it at that trace point. Still looks like maybe only one hit point, so I'm going to hit trace, and I'm going to zoom in one more time. I'm going to get right down here to the interesting point where it looks like they intersect, and I'm going to go zoom in. Ooh, that's really tight. Almost looks like lines now. Still looks like only one point, so I'm going to ask it what that is. I'm going to go second, calc, and intersect. And there's only one I'm thinking, so it's pretty close to it. I'm going to go enter, enter, enter. The intersection is 0, 0. You're going, that is what it says, Miss J. Now I need to teach you something else about your calculator. You can't see it on this screen, but you can on your own screen. Can you see the little teeny tiny rows or columns of squares, and then there's little rows of squares going up? Can you see them? Those are pixels. And sometimes your calculator has a difficult time landing exactly where it should. It's having a pixel crisis in its life. It's got a real trouble. And the way you know as the operator or the master of the calculator, not the slave, this means, listen carefully, this expression right here means 3 times 10 to the, that's how you pronounce that. 3 times 10 to the negative 9. Without having all the scientific notation, which takes so much printing, this is what this means. 3 times 10 to the negative 9. What that means is this. 1, 2, 3, 4, 5, 6, 7, 8, and 3. This is a pixel crisis. The calculator was having trouble landing right on 0. But that is 0. That is 0 for you. If you ever get a times 10 to the negative 6 or worse, meaning more negative, that's a 0. Can you see why this is also 0? So the point where those two things cross is the point 0, 0, if you know how to read your poor calculator that's pixelating crisis-wise. 0, 0, but we do not report it this way. How do you report it? What's the solution to this system? Or what's the solution to this equation?
0 because
X equals 0. Only the X coordinate. Why? Because, not why. Why? Because only X's were given to us. We forced this issue. So we must know to ignore it. The Y values when we solve the system this way. Not the equation. So it's a different use of the system idea where you force the Y issue and then you have to ignore it in the solution. Only X's count here. Turn a page and there you go. So there's two main skills. Both use the same methods. You got to know what you're doing, which one you're doing, how you're going to answer it, whether it's with a point or with just the X value. So be careful. Okay. For those of you doing it on paper, this is the assignment. When you're ready to write, let me know. A lot of you are still doing this on paper because you haven't passed the test with a 75 or better, so make sure you're doing that because I don't accept them when I see your scores in Big Ideas Math. You don't get credit. Got to be on paper or nothing. Okay, so it begins on page 136. This is section 3.5, and this is the assignment. 1 through 17 odd, 21 to 31 odd, 35, 36, 39 to 51 odd, and 55 to 57.
31 or 55.
55 to 57. No 60s, in case you were misunderstanding. Okay, has everybody got it that has to do on paper? You got it written down? Okay, let me know if I can help you. There you go. Call me if you have any questions.